Okay, let's dive in. We're going straight to the core today. The engine in your chest, the heart. Our mission really is to get past just the basic anatomy and look at the incredible, well, the physics and electrical engineering behind this fist-sized muscle.
Yeah. And the scale is just mind-blowing when you actually look at the numbers. Your heart beats something like 100,000 times every single day. Think about that. That means it's pushing around, what, 2,000 gallons of blood in 24 hours? It's relentless, like a city water system that just never, ever stops.
2,000 gallons.
Yeah.
That's hard to even picture. So, assuming folks know the basics, the four chambers, let's talk pressure. The blood path seems straightforward, right? Right side, low pressure, off to the lungs. But that left ventricle, that's where the real force comes in, isn't it? Why is it so much more muscular?
Yeah. It's pure physics, really. That left ventricle has a massive job. It needs to generate enough force, enough pressure to push that oxygenated blood out against all the resistance of your entire body's network of vessels. We call that the afterload. Goes out through the aorta, has to fight gravity to get up to your brain, friction all the way down to your toes. So its walls are thicker, naturally more developed, just to handle that constant high-pressure demand.
Right, which makes those four valves, tricuspid, pulmonary, mitral, aortic, much more than just simple gates then. They're not just stopping blood from flowing backwards, they're managing these huge pressure surges, keeping everything moving in one direction, like high-precision regulators.
Exactly.
Yeah.
Precision is the key word.
Yeah.
And that precise movement, that's the beat, the cardiac cycle. We talk about systole, the contraction phase when blood is pushed out, and diastole, when the heart relaxes and fills up again. But it's the synchronization that's truly remarkable.
Okay, so synchronization, this is where the electrical side comes in, right? We hear about the SA node, the sinoatrial node being the heart's natural pacemaker. But what's the deeper insight there? What makes it tick, literally?
Well, what's fascinating is its inherent rhythm. The SA node cells, just on their own, they want to fire off an electrical signal about 100 times a minute. That's its default, its intrinsic rate. But obviously, you're not walking around with a heart rate of 100 all the time.
Right, hopefully not.
Exactly, because the whole system is constantly being adjusted, modulated. Your central nervous system, through things like the vagus nerve and hormones like adrenaline, they're constantly applying the brakes or stepping on the gas. So the real miracle isn't just that the node fires, it's the incredibly fine-tuned neurological and chemical control that keeps your heart rate optimized for whatever you're doing moment by moment.
Okay, so tying this all together for you listening, this super efficient, pressure-managed, electrically timed system, its whole purpose is making sure every single cell gets the oxygen and nutrients it needs, and at the same time picking up the waste, like carbon dioxide, to get rid of it. Understanding these mechanics, the pressure differences, the electrical signals, that's really key to noticing when something might be going wrong, isn't it?
Absolutely.
Right.
It connects directly to why this knowledge matters. Knowing, for instance, that the left side is a high-pressure pump compared to the right side's low-pressure circuit to the lungs, well, that helps make sense of symptoms. Things like shortness of breath or chest pain. Often they signal a problem with managing those pressures or maybe an issue with that electrical timing we talked about.
Right. It gives context to those warning signs. So here's something to think about. That SA node, it's designed for this incredible endurance, keeping precise electrical timing for 100,000 beats day in, day out. Now, consider how modern life, chronic stress, maybe not enough sleep, what we eat, how those things directly mess with the chemical and nerve signals that regulate that baseline 100 beats per minute pace. Maybe the biggest challenge for us is simply giving this amazing natural engine the stability and support it needs to keep running that electrical marathon decade after decade.